So in this problem, we need to note that the angle phi is between the magnetic field B and the element area A. And notice that if the wire coil is making a 60-degree with the magnetic field and the area is perpendicular to that, then the angle phi, what we're calling phi, has to be 30 degrees in order to complete it to the 90 degrees needed to be perpendicular to the object. And we know that for a coil, that the induced EMF is minus the number of turns times the rate of change of the magnetic flux with respect to time, and this is minus n d beta or dB dt times a cosine of the angle between B and A, in this case phi. And if we plug in our values, we know our coil has 500 turns. The magnetic field is changing at 0.2 Tesla per second. The area is going to be the pi times the radius squared, 0.04 meters squared, and then cosine of 30 degrees. And if we do this, we find out that the induced EMF is 4.435 volts. And now for the direction, notice that the change in magnetic field is decreasing, so this has to be a negative, which I forgot to put before, and then the two negatives give us a positive sign. This positive sign means that when we point our right thumb in the direction of A vector, the direction of the induced EMF E has to be of that of our curled fingers of the right hand. So if we look at the vector of the picture to the left here, and we put our thumb in the direction of A, we notice that our fingers will curl in somewhat like a clockwise rotation. So using right hand rule, the thumb in direction of A, fingers curl clockwise